Hi, have you heard about Java virtual threads?
They don't exist.
They exist.
And some of you can say,
I know everything about them.
so let's explore about these Java virtual threads today in depth. These Java virtual threads are introduced as part of Project Loom in Java 17. Virtual threads is really a thrilling feature and where traditional concurrency models meet a new era of scalability and performance. So let us see why classical or platform threads are inefficient, what problems virtual threads can solve, how virtual threads actually work. Please subscribe to the channel if you are not yet subscribed and share this with your friends. Let us see how the conventional platform threads work and how they are inefficient compared to virtual threads. Platform threads referred to as system threads, also known as OS threads. These are managed directly by the operating system kernel. So take an example. Suppose there are 4 processes, process 1, 2, 3 and 4, and trying to perform different tasks, that is printing, accessing the database or making a remote network call and a video streaming. Suppose here 4 platform threads are available and these 4 processes occupied all these 4 platform threads. And these platform threads has to wait for the response from the IO operations or the remote network calls until these platform threads are also not available for other processes. So this is the drawback of the platform threads in terms of performance. Now let's try to understand how these Java virtual threads try to solve this problem. Actually, these virtual threads are created and maintained by Java Virtual Machine. And as you can see in the diagram, they are mounted to the each and every platform thread. Actually, in underlying JVM, there are 2 areas. One area is set of unmounted ready threads and another area is mounted and blocked threads. Those free and unmounted ready threads are keep stacking up in this area when there are more and more process requests are coming. Same thing with these mounted threads. When there are more number of blocked threads that are mounted on the platform threads, those are moved to the mounted and blocked threads area. If you consider example here the virtual thread 1 and 2 are mounted to platform thread 1 and 2 and they are in a waiting or a blocked state. So as discussed, these virtual threads 1 and 2 which are blocked with platform thread 1 and 2 will be moved to the mounted area and they will free the platform thread 1 and 2. Now the next process in the queue, that is 5 and 6, will hire the threads virtual threads 5 and 6 and they will occupy the platform thread 1 and 2. So this is what the special feature of the virtual threads. They can free up the blocked platform threads and they can make them available for the other processes. On the other hand, these blocked virtual threads, that is virtual thread 1 and 2, which are waiting for the response from the printer or a database, will perform their actions independently and whenever they got the response from the respective resources, they will return back to the respective processes. I hope now you are in a position to understand how virtual threads are efficient than our classical platform thread. Now let's dive into the code. We will make one example, then we will see how these virtual threads are working. First, I am trying to code a simple platform thread example. Here in a loop, I am creating around 1 million threads and printing how much time they are taking to execute all the threads. Now let's hit the run button, we'll see the output. Now threads were running. They will execute up to the count 1 million. And here it is. It was taking around 27,000 milliseconds.
They seem a little slow.
Now let's run the same program for a virtual threads and we will see how much time it is taking. Here I am creating 1 million threads similar to the last example, but here I am creating virtual threads using thread.offVirtual method. Make sure you have installed Java 17 and upper versions so that this option will be available for your thread. If this option is not available, make sure you have set the right Java compiler and enable the preview version of it. Also set the project SDK module to latest version. Let's run this program and we'll see a huge difference in the performance of the virtual threads against the platform threads. Now here you can see there were 1 million virtual threads were running. and the count comes to around 12,000 milliseconds.
This seems crazy.
Whereas in previous example we have seen platform threads were taking around 27,000 milliseconds. Clearly you can see the difference, the performance doubles with the virtual threads with respective time and resource allocation. I want to show you one more small example how these virtual threads were created and assigned to the incoming process requests. Here in this example I am trying to create 10 virtual threads in a loop, also printing the thread name. If we run this code, we can see the names of the virtual threads created. Here you can see we are trying to create 10 virtual threads, but there are only few threads were created, that is 1 to 7, and they are also getting duplicated here. This is because of the available virtual threads will be reassigned to the upcoming process request. That's all about in this video. Please kindly subscribe to the channel if you are not yet subscribed, and please share this channel with your friends. It motivates us a lot to make more videos. Thank you.